So, hi, I'm Yury. This is me 10 years ago at EuroPython, announcing uvloop and asyncpg. I have a lot of fond memories of that period of time. Like, for example, one morning, it was sunny. I was sitting in this beautiful Spanish cafe eating pastries. And then I read this disgusting tweet by Hinek saying, ha ha ha, Yury is missing at his own talk. I never ran faster in my life. I made it. Anywho, fast forward to today, something happened to me. I honestly don't know how I got here. I blame AI and LLMs. Anyway, forget about it. This is not me. This didn't happen. This is an AI-generated image. But I thought it would be great to repeat the uvloop announcement experience. Do it again. I mean, not announce the uvloop. Well, I guess I could in a banana suit, but instead we'll do something boring today and talk about FastAPI and Gel. So it all started about 100 years BC, and then we quickly evolved to C, C++, Python, and Rust. But what about databases? Oh, well. We started strong with SQL, but then something happened. And now I'm just not sure what part of the transaction we're in. So Gel is an attempt to fix databases for good and get us on the right fast-forward trajectory. Gel is basically what happened when Postgres and Python decided to have a baby. And I was somehow in the room. So let me preface this. Postgres is an amazing marvel of engineering. It's not a coincidence that Gel is based on PostgreSQL, that it wraps around PostgreSQL. I'm not throwing stones at it. I'm just analyzing the shortcomings of relational model in SQL. So there are lots and lots of gaps which you have to address one way or another. When you work with PostgreSQL, when you work with Python, when you try to build something that talks to both of those things. Like, for example, type safety gaps. Postgres is type safe, but there are some things that shouldn't be allowed, but they are. Like, for example, you can add a float number to a decimal number. This is nonsensical, but you can. Type system allows you to do that. Python also has its own type safety gaps and only kind of like type hints, not enforced at runtime things. It's really hard to work with hierarchies in Postgres. Postgres has tables. Tables are flat. You can join tables and whatnot. But doing hierarchical queries is really, really hard. Expressing hierarchical models is hard in Postgres as well. It's fundamentally not about that. But it is easy to work with hierarchies. Somehow you have to marry those two. Relational models is all about tables. And on top of it being inconvenient, it's also inconvenient for you to just even think about it and express your domain in tables. It's hard. We don't think in tables, at least anymore. And in Python, you have this amazing type system. You have amazing data model. You have multiple inheritance, powerful things. You have primitive types like arrays and tuples, but in Postgres, you do have them, but they are incredibly inconvenient to work with. So if I had to draw a line, what separates Gel from Postgres is absolutely religious type safety. It makes really easy to work with hierarchies and graph-like data. And it's inspired by Python, basically because I was inspired by Python. In fact, a lot of things like uvloop, asyncpg, async await probably wouldn't happen without Gel. Well, I mean, async await would definitely happen, just probably not by me. And both Python and Gel have incredibly rich data models, type systems, things like inheritance, arrays, tuples, all of that is supported. And it was designed from day one, Gel and Python, to appeal to engineers with elegance, composition, soundness. I think I better show you a demo. And to set the stage, this will be a masterclass on live demos. You know why? Because I'm learning from the best, specifically this guy. Some of you might have seen him next time you do report to authorities. But through years of knowing this man, I learned his moves. Now I know how to make amazing live demos. Pablo's method on live demos is as follows. Step 1, announce you will have a live demo. There is no step 2. In all seriousness, though, live demos are hit and miss. I wanted to do one, but fonts can be small, stress levels are high, so let's use the power of cinema. Here, we will create a new Python virtual environment, fresh. We install FastAPI in it. By the way, the demo will cover fully building a simple FastAPI application with Gel and FastAPI with some of my comments. For the curious, I'm using Fish shell and a plugin for Fish called Virtual Fish that streamlines management of Python virtual environments. Really makes it a breeze. Can't recommend enough. It's neat. Now we open IDE. This time of year it's Cursor for me, add our newly created project, and we have to configure Cursor to use the correct Python virtual environment so that MyPy and PyWrite and like all of those good things work. Now let's initialize a simple Python project layout, and now let's get to Gel. Let's install Gel, Gel library first, and then let's initialize the database. And what you see on the screen is actually quite interesting, because here we are installing Postgres and Gel, the entire development stack, and it took us just a few seconds. You don't need to type sudo, you don't need any of that. From this point on, the database is ready and awaiting for a command. You don't need to wrestle with hosts, port numbers, TLS certificates. It's all configured, it's all secure by default. A lot of people ask me, like, why Gel? Naturally, I have to answer to them. To keep track, let's have this slide, and we'll just update this slide with some takeaways. So basically, time to set up the full database stack and like a bare bones FastAPI application is basically seconds. Now back to our IDE. Let's make a simple hello world FastAPI app. So here we import Gel FastAPI. We then gelify our FastAPI application. Of course, we'll make it async await because we care about performance. And we'll just query the database straight away. Let's run FastAPI dev again. But wait, what do we see here? We actually see here that Gel, now that we gelified FastAPI, Gel is fully integrated in the FastAPI dev flow. Now it listens on file system events if you are changing the schema or any other files that Gel cares about. It will do things. So anyway, we'll see. Now let's check that the application is still working. By the way, just to make double sure, we'll change the string. Refresh. Here we see it, it's working. So let's update this slide. Basically, Gel ships with async and synchronous, idiomatic, high-performance APIs out of the box. By the way, we also have clients for Rust, TypeScript, Go, and many other languages. Now, your database can probably do more, usually, than just returning strings. So let's add some structure. Here we're adding a type to Gel schema. It's a simple type. Let's call it ball, because we need balls. It's going to have color property. And as soon as we change the schema, FastAPI and Gel notice that something happened. And they will start applying the schema to the actual database automatically. And it will generate you a Python binding as well. Let's actually click through what it generated. There's a bunch of scary things that you probably don't want to look at, but let's keep clicking. More interesting things emerge. Boom. Interesting. So basically, it's all based on Pydentic. So the Gel is a database. GelPython is a driver for the database. It can generate code for the database. And the code it generates is Pydantic aware. It's built on Pydantic. Neat. Let's update the slide. So basically, we already see that Gel takes away the pain of migrating your database. It feels like you're kind of working with MongoDB or like any other database where schema isn't like your first priority. You don't need to worry about it. You just do it. And Pydantic is first-class citizen. All right, now let's change our simple query. Let's import the generated code and let's query our balls. Rather unsurprisingly, we see an empty set, empty list. We don't have any balls yet. So let's add them. Let's split the terminal screen, get into the same virtual environment, and type Gel UI. And now we can see the full-blown graphical UI for Gel. It covers a lot of interesting things, like, for example, query performance analysis, authentication layer, AI layer, can visualize your schema. It has a web REPL if you are into that. Let's run some query. Most importantly, it has a data editor, which can replace your admin panel. So we created our type ball. Let's add an object of that type to the database. And now it's time to refresh the browser. Boom, we now have a ball. So updating the slide, we also have integrated rich graphical UI built into the experience. Let's move on. So we have just one type, and I mean, what kind of silly database are we? We have to do better than memcached. Let's add one more type. We go to the schema, we add a type called basket. This is where we can put our balls. And we can query it now. We basically just write our query in Python. You can notice the auto-completion pretty much everywhere in the IDE. So we select the balls link, and we want to select the color. Actually, no, let's just select all of the properties. And of course, this wouldn't be a live demo if we didn't hit a bug. Let's fix it. So basically what happened here is that we traversed the wrong link. The runtime checks saved us from them. We see, again, an empty list. Why? Well, we didn't actually add any basket to our database. Let's go back to the UI. Let's open the basket type. Let's actually create the data entry and link the one ball that we have. And now, refresh, boom, success. So total type safety is another thing that Gel will give you. It's the type safety inside the database, inside its standard library, inside its data model, in its Python API, pretty much everywhere. Now let's get back to our little application and just open Swagger. Let's see what is the open API spec. We can see that it's just string. Well, it's no good because we actually return rich data. So let's just annotate our function with our model that we just imported. And here we see that the type checker actually helps us. And this is an important point because the type system detected that the query returns more than one ball, potentially, but the annotation says just one. So we have to fix it. This is where type safety helps us. And everything is inferred automatically. So now we can actually see proper, nice, full type. All right, let's move on. Now let's take a look at the data modification API. We want to add another endpoint to add some balls to a basket. First, we need to find the basket by an ID, and then add a new ball object in it. So let's do just that, import UUID, and now we need to fetch the basket by its ID. This is trivial, we've done it before. So here I'm making a bug. I wish I could say I did it intentionally. I did not. But again, the type safety saved us. And now we were able to correctly and quickly fix it. As you can see, the type checker basically guides me all the way here. I'm making subtle mistakes. So let's return the basket by ID. Annotate the return type. Switch back to the UI, and basically let's just test the entry point. Let's copy the existing ID. And insert a nice magenta ball. And let's validate that it works. Yes, it did. To the next point. So basically, GelPython ships with an intuitive Django-style data manipulation API. We spent a lot of time thinking what the data manipulation API should be. Should we be inspired by SQL Alchemy, or should we be inspired by Django? And we decided to aim for simplicity. It's still more robust than Django API. It still has a lot of additional checks to make sure that you're using the API correctly, and that objects can't just like be dropped on the floor because you forgot to save them or things like that. But it's actually quite easy and approachable. As a sort of like data point, it takes just a couple of minutes or like one paragraph of text to teach an LLM or a human being to use this API without them having any previous knowledge of it. But then you might ask me, but what about performance? And I'm proud to report that Gel pretty much crushes everything in benchmarks. This is a realistic benchmark that we created. It's on GitHub. You can review it and test for yourself. If you don't like it, it's called IMDb Bench. Just go to github/geldata/mdbbench, and you can find it. But here you can see that somehow Gel is faster than Postgres, and probably you are wondering why. If it wraps Postgres, how is this even possible? Like what is going on? Well, it's important to say that Gel is basically a compiler. It's a huge, big piece of compiler tech, plus some I/O infrastructure. So basically, Python API generates HQL. That's our query language that we spent many years designing. That actually allows you to query graph-like hierarchies with ease. Gel then compiles HQL to efficient composed SQL. And composed, the word composed here highlighted not by accident, it's a feature. Basically, no matter how complicated your HQL query is, and it can potentially fetch a huge, deeply involved nested data hierarchy, it will be compiled to just one SQL statement, no matter what, which will execute atomically and fast. So you're saving on latency, because humans, when they write SQL by hand, and orbs, when they generate SQL, they tend to simplify it and basically do one data operations with multiple queries, which quickly balloons your latency. And with Gel, you never have to worry about this. You write a simple query in HQL, and you always know that it will be executed efficiently and basically in just one shot. There is a lot more to Gel that we don't have time to cover. It ships with an auth layer. You don't need to use Clerk or like any other services. You just use Gel. You enable the auth extension. You configure the database manually or through the built-in UI. You can connect it to GitHub or Google or any other OAuth provider. It supports magic links, email authentication, and pretty much everything else. It will even give you the UI if you want to do it. Like if you don't want to yourself implement a login form, you don't have to. You just need to write a couple of lines of code in your FastAPI, just add a couple of endpoints, and auth works out of the box. You don't have to worry about it. It has an AI layer, so you can configure it with Mistral and or OpenAI or Anthropic or any other OpenAI compatible API. And Gel will talk to them whenever your configured type is updated or inserted, when you add data or modify data. If you set it up, it will do it for you. It will generate embeddings for you. It will even give you RAG endpoint out of the box. And if you open the UI panel locally or in the cloud, you can literally chat with your database with the help of an LLM. It ships with GraphQL. It has robust access policies, which are actually becoming more relevant today than they ever were. Because if you want to implement agentic flow in your application, you want to basically be able to sleep at night. You want to know that your agent will not be able to share some data that it's not supposed to be sharing, or see some data that it's not supposed to be seeing. That data from one user cannot be shown to another, that your program cannot accidentally delete something that it shouldn't be deleting. And Gel has the most robust policies, access policies out of any database, frankly. It obviously supports all the standard database tech and some on top of it. Triggers, functions, query rewrites, HTTP calls, which are actually quite neat and allow you to implement real-time functionality if you're into that. It has libraries for TypeScript, Go, Rust, and many more. What I showed you today is basically a sneak peek, a preview at our new Python API. We've just shipped it this morning, actually. You can try it. It's pip install Gel, version 4.0, beta 1. It's a new thing. Thank you so much.
Thank you for your presentation. If there are any questions, feel free to raise your hand and I will give you the microphone.
This slide somehow wasn't displaying. I was supposed to open with it.
Fantastic talk, by the way. Thanks. It sounds too good to be perfect. So what are the drawbacks, frankly speaking?
The main drawback is that you will have to learn something new. And this is why I'm a big believer in AI, because AI will learn something new if you tell it so. Humans tend to slack, and basically learning a new database is a daunting task. While we spent years designing this and focusing on DX and whatnot, it's still a new big thing that you have to learn. So I would say that this is the biggest drawback. Ultimately, because of our decision to base it on top of PostgreSQL, your data is going to be safe. You know that. You can opt out at any moment. You can just run pg-dump on Gel, and it will happily dump you the entire database in PostgreSQL compatible format. But learning something new is something that you have to do. If you do, I think you are going to be rewarded.
And one last quick question. So it's 100% native Postgres, right? So as you mentioned, you can anytime pg-dump and supports everything that Postgres does.
We used to have a fork of Postgres because we actually use Postgres to its full potential. Like everything that Postgres has, we use that to implement Gel and its advanced type system and query language. So once upon a time, we hit a number of bugs in Postgres and a number of things that it was just missing. So we had to fork it. But over the years, we were able to upstream all the changes, fix all the bugs. So now Gel runs on vanilla Postgres. When you install Gel, you don't need to care about Postgres. It's kind of like the engine under the hood. But if you want, you can deploy Gel on top of AWS, Aurora, or anything else. We have guides on how to do bare metal, how to deploy it pretty much anywhere. But we also have our own cloud. So if you want a 30-second long deploy story, when you just like type one command and boom, your database is in the cloud, then just use our cloud.
Okay, thank you very much.
Hello. You were talking about auth layer and the policies. So does it mean that you have something like row-level security, that some objects of one type are accessible by some users and other by other users? That's one question. And other question is if it supports the existing Postgres extensions.
Extensions, yes. We have support for PostGIS and a bunch of other extensions. You can't just install an extension in Gel because you have to basically provide the type system, like compatible scaffolding around it. But most of the extensions that the community requested, we added support for them. So a bunch of them have it, and if you encounter a Postgres extension that doesn't have native support to Gel, just talk to us and we'll add it for you. It's fairly trivial for us to do. We will also have a proper extension system. in the near future when you will be able to do the work yourself if you want. And the first question was?
About row-level security.
Oh, yes. I believe that Gel access policies are more powerful than RLS. We don't actually use RLS to implement our access policies because Gel is a huge compiler, as I mentioned before. We just do some compilation tricks to make sure that the access policies rules are inlined in the queries as they compile. Surprisingly, that yields better performance than Postgres row-level security, but also it allows us to do basically whatever we want. Access policies in Gel, like the type system in Gel allows you to have abstract classes and multiple inheritance and mix-ins and all of those things. So you can potentially create abstract classes that have certain access policies on them, and then you mix those in, and your types inherit those traits. This sort of schema composition is just not possible in any database that I know of. But in Gel, it's achievable. And there is also another big benefit of having everything kind of vertically integrated that a lot of people overlook. Yes, there are there is row-level security in Postgres, but how do you configure it? Like typically you have schema in one place, maybe managed by Django or managed by SQL Alchemy or by SQL Model or something like that. And then row-level security is most likely configured somewhere else, maybe, I don't know, like in Supabase or some other cloud provider, or maybe you have scripts that set it up. Those things are completely split. And then you also have the SQL database, Postgres database, it has a concept of schema. It's kind of hidden behind the scenes. And with Gel, everything is just on the same page, always. Everything schema-related is in your files. It's committed to your project. Everything is generated from it. It's the center of truth. So managing access policies through it is just much, much more convenient than dealing with Postgres RLS. And the mechanism itself is more powerful because it just covers more cases.
Sounds good, thank you.
Oh, no.
Hi there. You went really fast, so I didn't quite get that part. That, like, you said that the generated client that you have, like, that to me looks like an ORM. You said that this is not an ORM. So, like, what's the difference between what you were providing and just using SQL Alchemy?
I did not say it's not an ORM, but maybe I did. I don't know. ORM implements the whole thing. It implements the actual mapping between relational model. So in your Postgres or MySQL, you have tables, and ORM maps those tables to your code. Gel Python doesn't do that because most of this functionality is done by Gel. So basically, the trade-off here is, do we as a species continue to make a library for every new programming language fixing the same hiccups for the same databases all the time? And then when we get tired of one ORM, we repeat the experience and make another one, and then make another one. And it's not necessarily clear that every successive ORM is better than the previous one. So the question is, can we actually fix this shit inside the database itself? Postgres right now is a layer on top of Postgres. Gel right now is a layer on top of PostgreSQL. It doesn't have to be. Eventually, it might embed Postgres and kind of fuse deeper within Postgres. But the whole idea here is just to fix this once, fix this problem once at the core. Elevate the data model of the database itself, come up with a better query language. So that is the job of the server that the Gel handles. Gel Python is a relatively tiny thing compared to something gargantuan like SQL Alchemy, for example, because it doesn't have to care about migrations. It doesn't have to care about how do I map Python to the data model. All of those things are handled by Gel. Gel is bigger than SQL Alchemy, much bigger actually. But that's the beauty of it. We solved this problem once, and now even though Gel Python has a certain complexity, and please don't see what we did to Pydantic behind the scenes to make it work, but at least it's much simpler. And what else it gives you is that your data layer is the same across all programming languages. If you have a project where you have Node.js and you have Python, and maybe you use Brainfuck or something else, the data is going to be the same everywhere. So you really don't care. You don't specialize your Node.js to work with data one way, and your Python code works with it another. They all see the same picture. This is the advantage of it. And this is why it's not a norm.
Thank you.
Unfortunately, we are running out of time. So I would like to thank you for your presentation, and please join me in a warm round of applause for Yury.
Thank you so much.